Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, dear students. Welcome back to this TV learning series program. As usual, I'm Teacher Patrick. I will be with you in Chemistry Senior 5, and we are still on Unit 5. If you remember, we are discussing the Unit 5, which is about alcohols and ethers. And our lesson today is a continuation of the previous lesson, and we'll also be looking at the chemical properties. And by the end of today, we'll be able to look at the esterification. We'll know how to write the equation for the esterification and what does it mean. We'll be able to look at the reaction with the concentrated sulfuric acid. But before we proceed, can we first go through some of the work that we did in the previous lesson, and we do the corrections together. Here is the exercise that we have to go through together. Number 1A, write a balanced equation to show complete combustion of ethanol. So we did that one together. You remember the experiment that we did when we were burning ethanol in air, and this is the correction. I hope you still remember this. So this is the equation for the complete combustion. So you have ethanol, which is C2H5OH, plus oxygen. Remember, it is a complete combustion, and this gives carbon dioxide and water. This reaction gives out heat, and that explains why ethanol can be used as a fuel, because when it burns, then it releases the heat. This is the reaction that takes place. We said balanced equation, that is carbon, there are 2, and then they will have 3, and then this is 2, so we have 3. That gives us the balanced reaction that we are required. And 2, what would you expect to observe if ethanol was reacted with sodium? Do you still remember that reaction that we did together? Because we did that one even as a demonstration. If you remember the experiment that we did. So this is part B. What would be observed? Do you still remember? Yes, I hope so. So bubbles of a colorless gas. So the bubbles of a colorless gas, or we can call it effervescence. Effervescence is the same as the bubbles of a colorless gas, or this is hydrogen gas, to be specific. And you remember we said this reaction can be used to test the presence of alcohols. So when all alcohols react with sodium metal, there will be the bubbles of the colorless gas. That is what would be expected. Copy and complete the reaction. We did even some of these reactions, if you can still remember, and we did even their mechanisms. How do they occur or take place? So if you look at this one, this is number 2A, Roman 1, sorry. So we have ethanol, CH2O5, reacting with the cyanoyl chloride or sulfur dichloride oxide, and this gives the product will be, so this is a nucleophilic substitution reaction. So you have C2H5, instead of the OH, that OH is substituted by chlorine, plus sulfur dioxide, plus the hydrogen chloride gas. So this is the reaction that takes place. That is a complete reaction. So Roman number 2, we have ethanol still combining. So we use ethanol to represent other alcohols. So when we are using ethanol, remember, it is representing other alcohols. So plus, this is the phosphorus halides. So all the phosphorus halides react with ethanol and then produce the substitution, nucleophilic substitution. So as we said, The OH will be substituted with bromine, and then you'll have the plus hydrogen chloride gas. So that is the products that are formed when we have these reactions. So far, these are some of the reactions that we did together. So we are going straight to look at we go to our lesson of today, which is going to look at the esterification. Esters are the compounds that exist in nature. You pass around in the compound and you feel a very nice scent or smell of some flowers. Those flowers are producing some esters. You enter into the house, and when you enter into the house, you feel the scent of the yellow bananas. You know that they are in the house. If the fridge is open or it is in somewhere kept, you know there are bananas inside. That is the smell of the esters, which are produced by ripening bananas. And then you have apple, you have pineapples. You feel that scent is as a result of the esters which are produced. So these are compounds that exist in nature. So they react with alcohols. For example, so let's start with esterification. As we mentioned, that reaction between alcohol. So we are going to use ethanol as an example. I said, remember, when I talk about the ethanol, ethanol is representing all other alcohols. So plus the carboxylic acid. This is a carboxylic acid. This reaction takes place in presence of concentrated sulfuric acid and heat. So it will give the ester, which is C2CH3OO, CH2, CH3, then plus water. This is the ester that is formed. So that is the structure of the ester that is formed. Let's look at the mechanism. How does it take place? Remember, this concentrated sulfuric acid is a catalyst in this reaction, and the reaction has to take place in presence of heat to increase the speed of the reaction. So let's look at the mechanism for this reaction. Consider so we have to go slowly and look at the steps one by one from step number 1. So we have the protonation, the sulfuric acid protonating the acid. So protonating the alcohol. So we call it a protonation reaction. So in the sulfuric acid first, will ionize to form the hydrogen ions and the hydrogen sulfate ions. So these hydrogen ions protonate the alcohol. So we have C2H5OH, then plus the hydrogen ion. So the lone pairs on the oxygen of the oxygen of the alcohol attract the hydrogen proton, and then it will form this product. This is C2H5O. Now this one will be, now there are two, because this one is added there. So you'll have, this is the hydrogen that is being formed here. So this oxygen, which has attracted the hydrogen, forms a partial positive charge. Remember, there is a bond here. So in this case, we will have the alcohol being protonated. So what happens next? Oh, I beg your pardon. I beg your pardon. I have to repeat this. So we have the protonation starts with the carboxylic acid. So I have to make a correction here. So the protonation starts with the carboxylic acid. So we'll have CH3COOH, and then plus the hydrogen ion. This one will produce CH3COH. This is the positive. The hydrogen that has come from the sulfuric acid and then forms OH. This is the carboxylic acid. It is the one that is protonated. So this hydrogen, the oxygen, will have to break. This bond breaks to neutralize the positive charge. As it breaks, then the OH of the alcohol which is C2H3. This is the same as this one, remember? So this alcohol uses the lone pairs because when this bond breaks, this carbon becomes positive. And therefore, we'll form CH3, you have oxygen and hydrogen. Remember, here we have a double bond here. Then we have OH, and then we have oxygen. This is the alcohol. This is a positive charge because oxygen has used its lone pairs. Remember that. Then CH3. So what happens here? There is what we call proton shift. Proton shift. And what do we mean by the proton shift? The hydrogen breaks away and it does not go away from that, so it rearranges itself in the same molecule. So this proton now either attacks this oxygen atom or this oxygen atom on the OH. So that means we'll have the product that will be formed will be CH3 after the proton shift. We'll have CH3. COH, we have O, assuming one hydrogen has come to this oxygen, so we'll form something like this one. So remember, when we say the proton shift, this hydrogen has to break to neutralize the positive charge. That is the proton moving. And therefore, we'll have oxygen with CH3, CH2, CH3. This is the product that is formed. So now here, the oxygen with the positive charge has to break away. And then that indicates the elimination of water molecule. So the water molecule is being eliminated. So we remain with what? So this is the molecule that we remain with. CH3, COH. Then you have O here. Then CH2, CH3. This is what remains. Remember, when this hydrogen, when this bond breaks to neutralize, this compound, this carbon here, forms a positive charge. And therefore, there will be rearrangement of the bonds. There is a positive charge here, so this bond breaks away, rearranges itself to form a double bond. So you'll have CH3, C, double bond with oxygen, C, CH2, CH3, plus the hydrogen that was formed. Remember, there was water. So this reaction also produces water, as we said, and you had elimination of water. So this is what is formed. Look at the hydrogen, this proton. This is the proton that we started with here. When a substance is not consumed within the reaction, it is referred to as a catalyst. So that is why this concentrated sulfuric acid is referred to as a catalyst. It is not consumed within the reaction. It is regenerated at the end of the reaction. So this is the ester, which is ethyl ethanoate. We'll come to the naming later on when we come to the esters. Don't mind about the name. But that is the name of that compound that is formed, which is an ester. Then we can look at remember we said we have to look at the reaction with concentrated sulfuric acid. This reaction, so this is the reaction with the concentrated sulfuric acid. How does it react? So there are three conditions which are necessary, which are required for the sulfuric acid to react with the alcohols. So here, we'll have at 0 degrees Celsius, concentrated sulfuric acid react with the alcohol. So start with the alcohol. So remember, we have used continuously the sulfuric, we have used continuously the ethanol to represent other alcohols. Then plus concentrated sulfuric acid. At 0 degrees, this will produce CHO, CH3, H plus the water. This is ethyl hydrogen sulfate. ethyl hydrogen sulfate. Ethyl hydrogen sulfate. This is the product that is formed, and you have to take note when the conditions that are used here. At 0 degrees Celsius, ethyl hydrogen sulfate is formed. Let's look at other conditions. At 140 degrees Celsius, that is the second condition, 140 degrees Celsius. What happens when this ethanol or any alcohol combines with the concentrated sulfuric acid? This is what happens. So you have ethanol, CH3, CH2OH, plus concentrated sulfuric acid. You remember we said the reaction takes place at 140 degrees Celsius. That is the condition for this reaction to occur. And this is the product that will be formed. CH3, CH2, or CH2, CH3, then plus water. This is an ether. Remember, at a later time, we'll have to talk about alcohols and ethers. We are talking about alcohols right now, but later on, we'll have to talk about ethers. And that is one of the reactions that produce ethers. Concentrated sulfuric acid with the alcohol produced at 140 produce ethers. Let's look at the mechanism for this reaction. So we have the alcohol being protonated by the sulfuric acid. This is the structure of the sulfuric acid. Oxygen, this is sulfur, oxygen. This is the sulfuric acid. That is the structure of sulfuric acid. So here, we'll have the lone pairs now protonating. The alcohol is being protonated. So attracting the proton from the sulfuric acid, and this one breaks away. And then this forms, this will eventually form CH3, CH2. Remember, this one will be forming water because of the hydrogen that comes from here. So this forms a positive charge. So what happens here is this bond breaks, usually to neutralize the positive charge. And that one will produce a carbocation. So this carbocation plus the water molecule, because there is elimination of the water molecule here, so even the water molecule. So this is the primary carbocation that is formed. So what happens here, in the next step, so this carbocation is attacked by the hydrogen sulfate. So this hydrogen sulfate can be written in this form, SO3. It is just the rearrangement. If you look at the reaction, there are 4 oxygen, 1, 2, 3, 4. Still here there are 4, and 1 hydrogen atom. So it's just a rearrangement. So this one comes here and then forms this compound. CH3, CH2, oxygen, SO3H. Remember, what happens here in the next step, because this product, let's come back to this product here. On this product here, I need to make some correction here, please. On this product, the primary carbocation that has been formed, this primary carbocation, this is a correction that we have to make, is attacked by another alcohol. So in this reaction, the alcohol must be in excess. This is something I had forgotten, that this is another condition. At 140, the alcohol must be in excess. So this is what happens. So if it is in excess, another alcohol with the same alcohol now attacking each other. So the lone pairs here coming to attack the carbon here, and then it will form CH3, CH2 with oxygen, but this oxygen has a hydrogen atom, so this will be a positive charge, CH2, CH3. So here what happens? this positive charge has to be neutralized. How? By this bond breaking. And therefore, finally, you'll come to CH3, CH2 with oxygen, CH2, CH3 plus the water, then plus the hydrogen. The hydrogen now combines with the ethyl hydrogen sulfate, that is, combines with the hydrogen sulfate ions, and then forms. Both of these together will generate or will regenerate the sulfuric acid. So the sulfuric acid at the end of the reaction is regenerated, and that is the reaction. We still have one reaction to go. I hope you have been following. We still have one reaction. So I will ask you to, let me request that I remove this part that we started with. I hope you have been writing so that we don't rub very many things. So those ones, hopefully I will not write them, rub them off. So this is one condition that is remaining. At 180 degrees Celsius. 180 degrees Celsius. So remember, we started with at 0 degrees, 140, and then we are going to now to 180 degrees Celsius. So ethanol will react with concentrated sulfuric acid. You remember this reaction somewhere because we had seen this reaction before. If you remember the preparation of alkenes, this reaction is coming back once again. So this will be, this one will produce CH2 double bond, CH2 plus water. Do you remember the type of this type of reaction, the name of this reaction? I hope you still remember this type of reaction. Very good. So this type of reaction, we called it dehydration reaction. Dehydration means removal of water. You take a lot of water to get, when you are dehydrated, maybe if you have spent a lot of the water, either you're running, you need to hydrate your body by taking more water. So the elimination of water is the dehydration. Or we can call it elimination reaction. How does it take place? Let's look at the mechanism for this. So you have, as we said before, CH2OH. This one is being protonated by the acid. As we said before, this is the sulfuric acid. And then lone pairs, removing this, and therefore this bond breaks. So you will form CH3, CH2 with water molecules. This is positive. So as we said below, before, this bond is breaking. So we have elimination of the water molecule, and then forms this carbocation, CH2 with a positive charge. So this carbocation now is attacked by SO3H. SO, this is the negative charge. So this one will attack this one. So we have CH3, CH2, oxygen, SO3, hydrogen. So look at what is happening here. This is CH2 with another hydrogen. So this bond, when the bond is breaking, this hydrogen, the bond that is attached on this, remember there were 3, so this hydrogen rearranges itself to form the double bond. So eventually you'll have CH2 double bond, CH2 plus negative SO3 hydrogen. So this hydrogen that has broken away, now this one will remove this one. And then eventually, you will have your CH2 being formed. Then plus this one now becomes sulfuric acid. This is a dehydration reaction. Dehydration reaction. So before we wind up, I hope I've been able to write all those. So before we wind up, I would like to give you a simple homework. Try it and see whether you can manage. This is number 1 of the homework. Write equation that represents esterification reaction. Esterification reaction using CH3, CH2, CH2O. So using that one as an example, this is propanol as an example of the alcohol. And CH3, CH2, COOH. This is a carboxylic acid, so it will be reacting with the propanoic acid. You represent that equation. That is A. B. Suggest the mechanism. Suggest the mechanism for this reaction. We have been able to do the mechanism. I hope you'll be able also to state the mechanism. Number 2, write equations to show how propan 1-ol reacts with the concentrated sulfuric acid. So when we say write equations, that means you have to consider all the conditions that we have stated. You still remember the conditions? We said there are 3 conditions that are stated at 0 degrees Celsius, at 140 degrees Celsius, and at 180 degrees Celsius. Those are 3 conditions. So you still need to consider those reactions. And this was A. B. Can you suggest the equation and the mechanism at 140 degrees? 140 degrees. Can you suggest the mechanism at 140 degrees for the reactions that you have stated here? I hope that has been very clear, and I've gone through all the work. Thank you so much for listening and watching. I hope to see you in the next lesson. Be there, please. Bye-bye.